If you want to check out our Twitch streams, it's twitch.tv/smAsho. My favorite streaming platform, period. Thanks to our followers over there. Also, thanks to our subscribers, new and old, over on BitChute. Please leave us comments and share the content on your social media. BitChute and BitChute users may be excited to realize that we'll be making some changes at smAshomash.com soon and creating subscription services over there. Thanks to our YouTube viewers as well. Thanks to our new subscribers, etc. Please share the content on your social media. Tell your friends and foes about the channel, as we need your assistance to grow the channel, since the algorithms have been, shall we say, less than helpful for the Smash News Network, least busted name in news. Today's cosmology segment should be interesting. First, we're going to go to the astronomy picture of the day. You can find it yourself at apod.nasa.gov. And today's astronomy photo of the day is a flyover. A flyover of planet Earth, which we officially announced was flat yesterday. I was just kidding, folks. You can actually see the Earth's curvature from this view. And yes, I know, it's because of a curved window, right? The curved window is making the Earth appear to be flat. I mean, to be curved when it's, okay, anyway. That's today's astronomy photo of the day, a great flyover from the International Space Station. And you can see some red and green aurora there on the edge of the imagery. The aurora borealis, folks. Let's talk about Petatrons. Now, when gamma rays reach the Earth, they cause a particle shower known as Cherenkov radiation. This particular gamma ray sensor here is known as the High Altitude Water Cherenkov Observatory. And this is interesting in that powerful pulsars are responsible for accelerating particles to the point where when they collide with things, they produce electromagnetic radiation in the more than 56 tera electron volts. So we're talking about trillions of electron volts here, folks. Trillions of electron volts. And we've talked about Petatrons before on the channel. Check out our cosmology segments. You can find the whole playlist. There are like pushing 200 videos there now. youtube.com/smashomash/playlists. We've talked about Petatrons before. This interesting article here about the source of Petatrons. Gamma ray producing pulsars. Let's talk about Comet Atlas C4, is it? Comet Atlas R4, yes. Remember, folks, never memorize something you can look up. That's a quote from Einstein. Comet Atlas R4 may become visible to the naked eye. Right now it's in binocular range. So this one discovered in September of 2020 by the Asteroid Terrestrial Impact Last Alert System known as ATLAS. Has been changing its magnitude a little bit. So this one may make it into visible territory soon. We'll keep you posted on that if it happens. And this is the image of Comet 1P Halley from back in the 1000s. And please leave us a comment if you're scared, spooked, and frightened. And there's a chart showing you where Atlas C2020R4 will be located from April 20th through June 1st. Showing you the constellations that it'll be moving through. What do you think? Do you have a forecast whether it will brighten and become naked eye visible? Again, it'll show up as bright as a moderately bright globular cluster right now. And there is some imagery of Comet R for Atlas. Not much structure to it yet. We'll be keeping an eye on it. And when I say ion, well, the pun is intentional. Today's random number is 397, which coincides with Safer 2 Galaxy, Swift J1200.8 plus 0650. And here it is on Aladdin Light. Great example of a Safer 2 Galaxy, and you can see the dust lane here, which is giving us some indication where the toroid is located. You can see this round feature, an indication that the jet is probably somewhat sort of like oriented like this. The opposing jet is probably somewhere something like this. You can see the torus is sort of like in this shape here. Safer 2 galaxies are a type of active galactic nucleus where it's pretty bright, but not as bright as, say, a quasar or a blazar. Let's take a look at it in a couple different frequencies here. Here it is in infrared light by the 2 mass, and you can see the heat signature of that totally different than some other signatures. Let's see if it shows up on pan-stars. There it is on pan-stars. Very high resolution imagery there from that observatory. And that is optical, by the way. And let's show you in Chandra as well. Doesn't show up in Chandra. Here it is on the multi-mirror XMM Newton project. The X-ray outputs from that. And let's take a look at another object, Proxima Centauri, as it is in the news as well. So this eruptive variable star, Proxima Centauri, is a red dwarf, and it's quite variable, put it that way. Red dwarfs are notoriously variable. Let's see if it shows up on the Chandra. There it is on the Chandra. Here it is on XMM Newton, as this is a binary system. How does it show up in blue light? And let's just put it on the XMM Newton. There's a great image of the Proxima Centauri binary system, folks. And this is an artist rendition of a massive outburst which occurred in 2019. So this article from phys.org's Astronomy and Space section entitled Humongous Flare from Sun's Nearest Neighbor Breaks Record. So this increased in brightness 14,000 times in ultraviolet wavelength. It also emitted radio burst at the same moment, something that we see from the closest star as well, El Sol, the local yellow dwarf known as the Sun. And Proxima Centauri, again, the closest star, quite variable indeed. This article again from phys.org's Astronomy and Space section. And that's today's Cosmology segment. It's time to say goodbye once again to Twitch. See you later, Twitch. We'll invite you back for the meteorology segment.